Hello fellow Scratchers, and welcome back to our RPG series. Our worlds are looking fantastic, but limited in size. So in this episode, I will introduce the concept of saving and loading multiple scenes. This is the basis for creating larger interconnected world maps, and for entering buildings, a much anticipated feature I know. So the active scene is stored in a list named Grid, containing around 30,000 tiles. This doesn't want to change as it's fast and efficient. To allow us to store many other scenes, we will introduce two new sets: store name, containing each scene's name, and the list store data, that will contain the scene itself. In computer science, this setup is called a key-value pair, or a data dictionary, and is super common. So, just like how in Scratch we can switch sprite costumes by name, so we'll be able to switch to an RPG scene by name too. Very cool. But before we can do this, we need a way of storing a scene, all 30,000 tiles of it, into one row of this new stored data list. Well, luckily my last tutorial named Save My Game, Data Serialization and Escaping in Scratch, has the answer for us. If you haven't followed that tutorial yet, then please do that now. And there's a link to the tutorial here. And here it is then. These are the two custom blocks that we are after. And I'm going to open my backpack and drop the entire sprite in there. These two scripts let us take lots of data and serialize them into a long single value, and then deserialize that back again into the original state. Exactly what we need. Okay, so open up our RPG episode 9 projects, and before we proceed any further, do not forget to save them as a new copy. It's very important this time, as any mistakes could mess up our beautiful levels. Guys, this is episode 10. Let's get scratching. We need to copy the two scripts from the backpacked save game sprite into the existing level store sprite. That's where we'll code up the saving and loading of levels. Cool. All our coding today is going to take part in the level store sprite, and those two helpful scripts can be moved well out of the way. Here we go. We'll begin by serializing, that is saving, the existing scene into a save code. A new custom block, save scene, will do this, adding a text input to give the scene a name, and then run without screen refresh. Start with a blank save code, and then we'll write out the first value, RPG. You see, it's common practice to begin any serialized data with a header, such that when we load this data back, we can then check the first item and confirm it matches the header we were expecting, RPG, a safeguard if you will. We can see that in action by clicking the save scene, and save code reports RPG. Great, we've begun! Next we want to add the contents of the grid list itself. We will call this a data module, as there may be more types of data to store in the future. Let's create a custom block for this named write module, grid. Drop that in right after writing the RPG header here, and now each module will, like the save code itself, have a header value. This one named grid.1. This means it's the first version of our grid save module. Saving the scene shows RPG bar grid1 bar. So good so far. Next we write gmax. That's the width of the 2D grid, 100 tiles across. And for completeness, we'll also write the height. Also gmax, since our tile map is square, but let's not assume that won't change in the future. And the save code is getting longer. Love it! Right guys, this is where things get a little more fun. The grid list we want to serialize contains a lot of data, and it'd be preferable if we could shrink it down a lot as we save it away. The technique we're going to use is called Run Length Encoding. It's useful because our grid list contains long runs of the same value. Now, rather than storing 79, 79, 79, 79 10 times, we instead store just one 79, and before that, the count of how many there were. 10, 79. That's a run of 10 79s. See how much smaller that is? And that's run length encoding. Let's do it! We need a variable GIDX for this sprite to keep track of where we are in the grid list, and set that initially to 1, the first item. And then we need a variable tile for this sprite that keeps track of the actual tile in the list at this position, from item gidx of grid. Finally, a variable count for this sprite, so we can keep track of how many tiles of the same type we've found. And right now that's just one, the first tile. We can use a repeat to loop through each item in the grid list, repeating for the length of grid, except subtract 1, since we've already got the first item. Now changing gidx by 1 to move us on to the second item. And then, with an if-else block, compare the next grid item with the previous tile. If it's the same tile again, we change count by 1. Now that's 2 tiles of the same type. Great! We'll repeat around again and check the next tile, until finally, boom, we hit a different tile number, and then we need to take action. First, we write out the previous count, how many tiles we found, followed by the previous tile number, and then set tile to the new tile type, item gidx of grid, and reset count back to 1, the first of a new run of tiles. Okay, so that is pretty much the shape of it. We loop around counting up runs of tiles and record the results when we find the next tile type. But be careful, because when the repeat loop ends, we still have a tile and a count to record. So pop in a final write count and write tile down below the loop as well. Perfect. Lastly, we'll terminate this grid module with a single write end. And then, I think this is a great time to give this another test, don't you? Save scene. Oh yeah, wow, so as expected, this is now much longer. Just how long though? Length of save code. Oh my, almost 11,000 letters. That's still pretty large, but then my scene is pretty complex. But comparing this to the uncompressed grid list at 34,000, well, we've managed to shrink it by a third of its original size. So good job. Let's scroll back to the save scene custom block. With the save code complete, now we want to store it away in our scene dictionary, which we haven't yet created. So make a list named store name for this sprite. First thing to ask is whether this scene name is actually in the list. Use the item hash of list block. This gives us the item number of the input variable name, if it is found in the store name list. We'd do well to keep track of this number, so make a new variable store hash for this sprite, and pop the item block in there. Now, if we didn't find the name, then item hash will be 0. In that case, this is the first time we've tried to save this scene. No problem, we just add it now. And then ensure store hash is also updated to the same new row number. We could use the item hash to find it again, but why waste time when we know it's the last item in the list? Test that with a save scene with the name cake. Nice! A new item for cake has appeared, and store hash is 1. Importantly, no matter how many times we click save, we only get the one item added to the list. Now, saving under another name is a different story. For that, adds a new row and updates store hash to 2. One last test now though. Try saving as cake again. Perfect. Store hash goes back to 1, the first scene. Exactly right. So that's the name stored. What about the scene data itself? We need another list. Store data for this sprite. To keep them in sync, whenever we add an item to the name list, we also add an item to the data list as well. A blank value at first. Before we can test this out, we must first manually delete all the values from the store name list. Very nice, a matching value data pair, but the data is very empty. Let's stuff in the save code. Replace item in the store data list at position store hash, and push in that serialized save code value. Exciting stuff! Running the save scene again, and now the save code is indeed showing up in our data store. That is so cool. You can try saving under different names, and this should all work tickety-boo! Of course, cake and fish are not the most suitable names for our scene. I'll delete all those for a fresh start. To keep track of the active scene we are viewing, make a new variable, scene name for all sprites. This first scene can be named over, short for overworld, but tack on the end :0:0. This will allow us to have multiple overworld scenes. In an XY grid, the scene to the right of this one would be named over:1:0. Click to set the variable and save the scene officially now under the correct scene name. Brilliant! We are making serious progress. And now for the second part of this episode, where our attention turns to the loading of scenes. If we look back at the first script in this sprite, we have a when I receive store load scene. We set this up yonks ago, and it's called right at the start as our game begins to run. Originally, we were generating a new map each time. Well, now we are going to load a new scene, with a given input name instead. Run without screen refresh. As the game begins, make use of that block and drop in the current scene name to be loaded. I'll define the new block over here next to the save scene so we can compare. Indeed, as we want to load the save code from the level store, we use the same set store hash and if check that we used in the save scene. Only when the scene doesn't exist, we'll instead generate a fresh new map. And just stop here. But if the scene does exist, then yay, set the save code to the item in the store data that matches the name we just found. It's at item storehash 2. Before we can start reading values out of this save code, we must set save index to 1. This is the start of the save code and is used by the read value custom block. And so we read our first value from the recovered save code. Do you know what value we are expecting? Well, it should be the save code header, RPG, right? We can test that easy enough with a load scene name. Click that and then check out the value of our value variable. RPG, perfect. But if this wasn't RPG, then we should not continue to load the save code. We'll also pop in an ask block to pop up an error loading level message, and then stop this script. The next value we'll read out of the save code is the module name, grid1. But don't assume this will always be the case. Modules may be in any order in the future, so we'll use a forever loop to read through the modules. And check if the value, the module name, contains the word grid dot. So any version of the grid will be accepted here, 1, 2, 3, etc. Let's make a new custom block to load this module. Read module grid, and we'll make use of it right away. The else is run if the module was not a grid. In that case, we check to see if this is actually a module at all. If blank, then we are at the end of the save code and we can simply stop this script. All is done. The last case is that we found an unexpected module, so another error, I'm afraid. Unexpected save code module. And we can join that to the module name we just found, so we can tell why it went wrong. And then stop all. Now let's go back to the read module script and move it to line up with the right module grid script. Firstly, we won't have to worry about reading in the module name as that's already been read for us to get this far. So the next thing to read will be the grid width, Gmax. So set Gmax to value. But I'm going to round this value to ensure it's stored as a number, and this can improve performance just a little bit if the variable is used a lot. The next value is the grid height, and we can just read it in and throw it away for now as our level grid is a square. Right, next up is the run length encoded grid data itself. Before we begin reading, we do well to delete all of the grid to start afresh. Now we'll loop around, reading the run length count and tile type values. However, by reading the first value outside of the loop, we can repeat until the value equals end. That means we've reached the end of this module. Otherwise, we loop, setting count to value, so we can read another value from the save code, this being the tile type. So we use these variables to add a run of count tiles, adding the tile type stored in the value variable to the grid list. Finally, before we loop back around, we need to read another value, Again, this will be a count or the end value. Brilliant, the module is loaded. Let's nip back to the load scene custom block then. And once our grid module is loaded, we'll loop back around for another module, and should find a blank value as there are no more modules to be read in at this time. So back to the when I receive store load scene. And well, that's it. That's all it does. So job done. This is where things get a little bit dangerous. We need to test our loading code, but as soon as we try to load a scene, if it fails, then it's quite possible we'll mess up the current level. You may like to save the project as a new copy right now to ensure you can go back to the previous one, or you can export your grid list to a file, which again can be re-imported if things go wrong. Okay, enough warnings, here we go. I'm clicking the new map block. This will clear our active scene, so say goodbye. If we want to see this blank scene, then separate off the load scene block temporarily and then run the project. Yep, it's gone. My wonderful level has been reset. But if all has gone well, then it's still stored safely away in our scene data list. So fingers crossed and smash that load scene block. And yes, phew, we did it! The level has been restored. We can have a walk around and make sure it all looks exactly as it did before. This is great. The load scene block can be hooked back up to the event receiver so that we can set the scene name to any name we want, and when the game runs, we'll begin with a fresh new map. The new scene is not added to the data store until we manually hit the save scene block, like so. But this is great, as we can then save and load these scenes at will. Of course, it won't be perfect until we can do this directly in the game and from the level editor. So in the next episode, we will be integrating this with the level editor, and we'll introduce scene transitions as we move off the edge of one scene and enter another. I'm really looking forward to that. Are you? Well guys, I hope you enjoyed this tutorial. If you did, you can show your appreciation by smashing that like button, and do comment under the video if you have any ideas or just to say hi. Also, if you haven't already, now is a great time to subscribe to the channel so you get notified as soon as the next exciting video drops. That's it for today. Thanks for watching, have a great week ahead, and scratch on guys.